Welcome, everybody, to this short little lecture on how to read architecture. We tend to live in boxes. We live in boxes, we work in boxes, we play in boxes. And these boxes can be cubic, like the one in the upper left. They can be tall and skinny, like the one on the right. Or they can be long and skinny and lying on the ground, like the orange one here. But it happens to be true that in most buildings are dominated by right angles and are box-like in their qualities. But having said that, there are some interesting variations. These rectangles that I have put up on the screen right here, they look like just geometric shapes. But as soon as I start adding elements to them, they start to look more like buildings. Because even though the buildings we live in tend to be boxes, they also have articulation of their outer surfaces, which include windows and doors and other types of decorations. So while we may live and work in boxes, the boxes are not quite so boring as we might think. In other words, to study them, we need to take a look at not just the size or the shape of the building, but also how its elements are organized. Say, for example, the high-rise on the very right-hand side. Its windows could all be horizontal. But if you put, say, for example, a series of vertical lines on its facade, the height of it is accentuated by those lines. So visually, it expresses something slightly different than it would if, say, for example, those lines were horizontal and wound around the building. Now, take a look at the orange building down here. I can put the same types of square windows, and you could ask yourself, well, how would it look different if there were long rectangular windows, if they were vertically oriented or horizontally oriented? They would look different in each case. So, for example, if I was to ask you what the function of this building was, if there were just these 4 square windows on it, well, you might ask yourself, well, how big is it? Is it 50 meters long? And if so, you might say, well, this building I think is some kind of a factory or industrial building. But let's say we change the articulation of the exterior of the building. Let's say we make it look more like this by adding arches. And you see how this rectangle is completely transformed by the different surface articulations. Now, this is a simple introduction to these ideas, but of course, even though there are lots of rectangles in architecture, those rectangles are often composite. In other words, there's rectangles stacked upon rectangles. Look, for example, how different this is, where you've got a box on top of a rectangle. And we could play all of the same games with surface articulation that we've done in the other ones. And you notice how they really do look more building-like. Well, these are the decisions that architects have to come up with all the time. They're given a particular site, they're given a particular budget, they're given particular needs of the person or the institution that's paying for the building. But then they have to also add some style to the building. So there's certain stylistic decisions that are made by architects when they are putting their building together. Now, this idea of rectangles and the rectilinear built environment that we've created in all of our cities, if you think about it, there are very few buildings that are cylindrical if we stick to the idea that geometric shapes, the basic geometric shapes, inform the shape of architecture. I'm sure that there's not very many cylindrical examples of architecture that you can think of. Maybe if you live on the prairies, you could say, oh, well, actually some grain silos are like this. Okay, that's fair enough. If you're from Los Angeles, you go, oh no, there's that one, you're coming down on the 405, you're coming, southbound on the 405, bottom of the hill below the Getty Center. There's that one on the right. Yes, but the fact that everybody from Los Angeles is now going, oh yeah, I know the one he's talking about, shows how few cylindrical examples of architecture there are. And what about pyramidal architecture based on triangles? Well, there are so few examples of that the one place where there is a number of these buildings, they are not very imaginatively simply called the pyramids. Of course, if you don't have enough money to go to Egypt, well, there's always Las Vegas. Well, here's an interesting example. Some of you may know this building. This building is in London. And this is quite a fascinating building because in a way, it's the marriage between a cylinder and a pyramid. This building has been given the endearing nickname of the gherkin, like a gherkin pickle. And some people don't like it, but it is, whether you like it or not is really not the issue here. The issue is, what have the architects done to articulate this building? So they've chosen this rather rare shape for a building, a kind of rocket shape or a kind of bullet shape. But on top of that, they've made certain decisions about the surface articulation of the building. So you'll notice that there actually is, the windows of the building actually are all horizontal, right, around the circular part of the building. But then there is a secondary sheathing of glass, and this is organized in a completely different way to affect the visual aspect of the building. And what you have here is both clockwise and counterclockwise lines, right, that cross each other as they wind towards the top. So what this creates is a series of diamond shapes, all of which are kind of pointing upward. On top of that, what they've done is the glass is clear on 2 of the rows and then dark on a wider row. So you get this striping effect that augments the spiraling aspect of the building. So there's lots of interesting things going on in terms of the dynamic of the surface articulation of the windows of this building. It could have been made in a completely different way. And I want you to try to imagine what it might have looked, organizing this surface in different ways. Would it have been, more, less kind of vertically oriented? One of the things that these designs here really seem to make it like it's kind of like a flame rising up to the top. Now, another thing that I want to bring up while I have this image here is that when you study architecture, you shouldn't just study the building itself, because the building itself also has a location. It has a site. And so, for example, this picture I like because the modernity of the gherkin is contrasted with a 19th century French style building, a neo-Gothic building that is put on top of probably a real medieval remnant of an old wall or church, and then a Neo-Palladian building there. And then, of course, you've got this pretty ugly 1980s square high-rise here as well. So you've got 4 different architectural styles in the same place. And of course, our understanding of the gherkin, to some extent, is based on how we might compare it with the other architecture that surrounds it. And this is architecture, of course, that the architects were aware of. They knew where the building would be, and thus they also knew what kind of views of the building you could get and how it might look in comparison to the other architecture around it. Now, if you think that pyramidal and cylindrical examples of architecture are rare, what about spherical architecture? That's even rarer. But there are some examples. Here's the example of the World of Science building in Vancouver, which was built as part of the World's Fair in 1986. Now, I call it a sphere, but it actually is not a sphere. It's really it's a geodesic sphere, which is really a polyhedron. If you notice, it's faceted, and the facets are all equilateral triangles. So even this one is not actually spherical. It's more something like that. all of the mathematicians and people who like trigonometry would love this. Now, buildings are complex objects, and architectural historians and art historians who study architecture have come up with different ways to understand buildings and to analyze buildings. Now, one of the ways to analyze a building, and this is certainly something that also architects use to try to make sense of the buildings that they are designing, is to create a plan. Now, the plan of a building is kind of like its footprint. If you take away everything at the top and it's almost like you took the building and made a rubber stamp out of it, and what would the rubber stamp look like? And so these are all the things that are the fundamental, basic, foundational elements. It's ground plan, its footprint. Now, sometimes, however, in ground plans, there is an indication of some of the superstructural elements of the building. For example, in this plan of Hagia Sophia in Istanbul that I'm showing you here on the left, you'll notice that there are these dotted marks, half circle, circle, and these X marks. These all refer to superstructural elements of the building. For example, the circle represents the dome of the building. The half circles represent the half domes of the building. The crosses, the X's in the squares, those represent cross vaults or vaulting. So one of the things to read a plan, you have to know the language of the plan, the standardized language of the plan. So for example, can you tell how the plan shows that there are windows? If you look at the outside edges, especially along the top and the bottom, you'll see these little black marks, right? And those correspond to the windows or the openings. So even though a ground plan does show the ground plan, it also does contain some information that tells you something about the superstructure. However, another very useful way of conceiving of the complexity of a building and giving it some graphic representation is something called an elevation. Now, the elevation, you can probably guess, is okay, everything that's not the plan, right? It's not a bird's eye view like the plan, but it's a sidelong view. Now, there's also two ways to look at that. This particular elevation that I'm showing you here, same building, right? This is an interior elevation of Hagia Sophia. So in other words, this building is sort of like if you took the plan on the left-hand side and you made a horizontal cut right down the middle and separated it and looked in at the side, this is what you see. You can think of it as a big cake that you've cut in half and revealed everything that is inside. Now, an interior elevation, of course, is different from an exterior elevation. So there's the interior elevation that I just showed you, but there's an exterior elevation, and you can see what the difference is. The interior elevation is a view that you could never actually get in reality, but the exterior elevation is what the building looks like from the outside, from a sidelong view. Right? And of course, if you were really going to do a lot of elevations, you would do one from the south, one from the east, one from the west, one from the north, and the building would look different from each one of these elevations. So these are some of the ways in which architects and architectural historians and people who write about buildings, these are some of the ways that they can give readers or viewers or other people an idea of the architectonic elements of a structure. Now, some of you who are artists may know about vanishing point perspective or linear perspective, and the tools of linear perspective also are very useful for people who do illustrations of works of architecture, especially when, say, for example, they want to do what's called an isometric view of a work of architecture. And here's a pretty typical isometric view, which is a kind of a cutaway at an angle. You notice how it's usually at a kind of upper angle looking down on the building with part of it cut away. And the person who drew this has had wonderful skills in terms of their perspective because they've drawn the whole building into perspective. So between plans, interior elevations, exterior elevations, and isometric views, these are ways that we can graphically understand a building and all of its complexities. Now, still, even though we may have these illustrations that are very useful in helping us conceive of a building, it still may seem like a very complex object, and indeed it is. But let's return to our interior elevation of Hagia Sophia, and I've blown it up a little bit here, because you might look at this and go, oh gosh, how do I make sense of this? How do I analyze this thing? Well, even though the building looks very complex, there's certainly ways in which you can reduce its geometry to some very essential features. For example, rectangles. If you start looking for rectangular elements, you start to find many of them. Okay, so many of the sections of the building can be reduced to rectangles. Now you'll see that in between here there are these columns, but in between the columns there are also rectangles, right? So you could make many small rectangles. But then of course there's another architectural element here, and that is of course arches. So the arches are half circles, and the dome is a half sphere. Okay? And if you start looking at these half circles, you start finding them everywhere as well. So between half circles and rectangles, you really get a sense of how the geometry of this building is constructed. And this is really key in terms of understanding a building, is to get at its essential geometry. Well, some buildings are easier than others to do this with. And the architecture of Frank Gehry, some of you may be familiar with his work, probably his most famous work and one of his first examples of this kind of expressionistic architecture was the Guggenheim Museum in Bilbao. But more of you are more likely to be familiar with the Disney Concert Hall in Los Angeles. Now, if you consider the geometry of this building, you realize that its geometric masses are much more complicated than just circles and squares or triangles and rectangles or even pyramids and cylinders. This is an architecture that really could only have been built with the use of computers, because only computers could have calculated all of the permutations of the curves of the building. You really need the processing power of a computer to be able to make sure that each one of these titanium plates fits within the whole context. So in some ways, Gehry's architecture to me is the most contemporary, the most modern, because it was really the first architecture that was the architecture of the digital age. And I like Gehry's architecture. And one of the things that I'm going to talk a little bit more about later is that, yes, you always ask about the geometry of the building. You also talk about the windows and, all of that kind of thing. But another important thing to ask is, what is the building made of? What material is it made of? And is it made of steel? Is it made of glass? Or is it made of a very interesting reflective material like these titanium plates that he uses in his works? Now, I like Gehry's architecture for other reasons, because it's one of the first architectures in many, many centuries that it utilizes curves rather than rectangles. Another great example of Gehry's architecture is the Louis Vuitton Foundation in Paris from 2006. There's its plan in the upper left and an aerial view of it in the lower right. And here too, you can see how you would really need to have computer processing power to articulate each one of the pieces that this building is made out of. Each piece of steel, each girder, each pier, each pillar, each column, each section had to be custom made, and this had to be fed into a computer, which would of course help produce the actual piece of the building. Another thing I like about Geary and his introduction of curves into architecture is that some of the first architecture known to have been made by human beings in the Neolithic period was also characterized by curves. So, for example, this is a temple on the island of Malta, which dates from 3500 BCE. And it's interesting because it kind of reminds me of the Louis Vuitton Foundation building by Geary, in that it uses curves and it's not quite so, how should I say, organized the way that rectilinear architecture is organized. It's much more freeform, much more open, much more playful in a way as well. One of the ways you can analyze architecture is by just thinking about the basic elements that you have to deal with. Sometimes I like to think of a work of architecture as a kind of machine. And for a machine to work, all of its parts need to be there, and all of its parts need to function properly. For architects, unlike, say, painters and sculptors, there are some pragmatic elements that they have to think of. The building has to stay up. The building has to fulfill its function. If it's supposed to be an apartment building, well, you have to be able to have plumbing. You have to have electricity. All of these, you have to have bathrooms. So all of these things have to be taken into account. So style is not always the main focus of architects, which is why we have so much architecture that has little or no style. But the idea here is that when you're studying it as an art historian or an architectural historian, how do you address a building? How do you approach studying it? Well, the first thing is form. And form we've already looked at. Is it a box? Is it a cylinder? Is it a sphere? If so, what are the ratios of this box? Is it skinny and high, or is it low and long? And buildings also have styles that sometimes can be categorized. Like, for example, when I looked at the Gherkin and looked at the buildings that were around them, and I said, well, this is a Neo-Palladian building, and this is a 19th century French style, and this one is a Neo-Gothic style. So these kinds of elements these kind of period style elements can also be very helpful in articulating the look of a building. But as I mentioned before, the material that the building is made of is also crucial. What kind of textures does it convey? Is it got that smooth, clean, dull, reflective, metallic surface of the work of Frank Gehry? Or is it made of glass like a high-rise, or steel, or brick, or stone? And how is this brick or stone arranged as well? Because you can leave the stone rough or you can smooth it off. So there's lots of different ideas or lots of different ways that you can approach these questions. Really, the idea here is that this is a way to approach architecture by asking a series of questions about it. Now, form and function, of course, we've already mentioned these two things are linked. Why is it that we can look at buildings and almost immediately we know what their function is, right? Why? Because buildings of particular functions tend to look the same, and we've walked around the world in our lifetime. We've seen many thousands of buildings in our lifetime, so we really get a sense of the standardization of what those buildings look like. So functions and forms are often really closely linked. But another thing that I've alluded to before, and this is the issue of site. So while we're still kind of looking at the issue of form and asking ourselves about function as well, is it a religious building, a residential building, an industrial building, right? There's also this issue of the site. Where is the building meant to be? Is it a kind of urban environment? Is it a suburban environment? Is it supposed to exist out in nature? Is it on a hill? Is it by a river? Is it by the ocean? These are all issues that are crucial in terms of understanding and analyzing the siting of a building. Well, I showed you before a picture of Geary's Disney Concert Hall. Well, this is a picture of the exact same building, but notice how different it looks. In the previous picture, it was a slightly cloudy day, and so the titanium mostly looked pretty dark, right? And you didn't see any other buildings in the background. Well, look at this. This is kind of interesting because all the buildings that surround this concert hall are, what I like to call boring boxes, right? Every one of them is a rectangle. Every one of them has rectangular windows set in a kind of monotonous series. They're all different, but in a funny way, they're kind of all the same as well. The only one that's really dramatically different is the curvaceous architecture of Geary. And notice the surfaces are so different. There's no windows here. And look at how the surfaces. This is what I like the titanium surface is that look what it does with the light. Now, if you look at the high rise in the background, the tallest one, you've got one side of it is lit and the other side of it is in shadow. Okay? But look at the play of light and shadow on Geary's architecture. There's parts where the sun is reflecting very brightly on it. There's parts where it's in shadow. And there's parts where it's in shadow, but it's getting lit by a reflection from another part of the building. And so it's a much more dynamic kind of idea. Well, talk about architecture that is made for a particular site. Many of you may know this very famous American building by Frank Lloyd Wright called Falling Water. This house, it's a residential building. This house was built in the middle of the forest, and so what Frank Lloyd Wright tried to do is he tried to find a place and design a house that would fit in the architecture. Now you'll notice that above the stream there are these large horizontal outcrops of rock. So what Frank Lloyd Wright did is he made these horizontal projections of the house to echo the actual geography of the place. And he also did some terracing so that and he really integrated the stream. The stream actually goes under part of the house. And when he built the stone walls, he used the same stone that was found in this particular area. So it matched the building with the environment or the setting or the site where it was meant to be. So in summation, if you are going to pick a topic or analyze a work of architecture, first of all, look at the size, the shapes, the geometry of the building. Then consider its plan and its elevation. Analyze its surface articulation, windows, doors, insets, perforations, positive and negative, projecting and receding spaces. Now, a projecting space is going to pick up the sun. A receding space is more likely to be in shadow. Okay, so there are interesting rhythmic aspects to this. Consider the surface and the textures of the materials, brick, stone, glass, metal, wood, and so on. And study the site of the building, its relationship to the surrounding urban or natural environments, its topography, its geographical location, and consider that it can be looked at from different points of view. The ancient Greeks always put their temples on the highest point of the city, the Acropolis, which literally means high city. So they always wanted their religious buildings to be seen from afar. And of course, well, there's lots of interesting things happening with architecture that have to do with trying to create environments that are, say, more green. And you could get maybe more green than the Bosco Verticale in Milan, the vertical forest. There's actually two buildings. There's another one off to the left. And apparently there are 300 bushes. They call them trees, and some they're small trees. But it does, in fact, offset some of the carbon that is created by the building itself. Anyway, another thing to think of is rhythm, because in this particular high-rise, notice that the terraces of the apartments are all different. They're all sticking out at different areas, right? Okay, and so there's a different rhythm of this. And you know, the famous 18th century philosopher and writer Goethe said of architecture that it is frozen music. And that's a very interesting quote to leave you off with, to think about how architecture communicates visually. Thanks very much, everybody.